Sakana AI just shattered the limits of how language models learn and adapt. Their new AI is so advanced it can reprogram itself in real time to handle brand new tasks, no retraining, no extra data, just instant adaptation. This is a monumental leap, and it's all thanks to their groundbreaking Transformer Squared model. Then later in this video we'll uncover how DeepSeek's latest open source model is beating OpenAI's flagship one, not with billion-dollar funding but with a budget that's closer to the price of a mid-range smartphone. How do they pull this off? Stay tuned, because this is the kind of innovation that's rewriting the AI rulebook all. Right, first off, let's look at Sakana AI. They're an AI research lab that's all about nature-inspired algorithms and super flexible systems. They've recently introduced a language model called Transformer Squared, which, if you can believe it, can learn new tasks without the usual time-consuming fine-tuning process we've all come to know and, well, not always love. Typically, when you want to tailor a large language model or LLM to a new task, you need a specialized technique like LoRA, which is low-rank adaptation. LoRA helps by only tweaking a subset of the model's parameters, saving time and money compared to retraining everything from scratch. But SAC's approach goes a step beyond, letting the model dynamically reconfigure its own weights right there during inference. It's kind of like having a machine that retunes itself on the fly whenever it sees something new, rather than needing a separate big training session for every single new requirement. So how does Transformer Squared actually pull this off? Well, the short version is that it uses a linear algebra method called singular value decomposition, or SVD, to break down the model's weight matrix into smaller components that represent different skills like math, coding, or language understanding. At training time, SACs researchers develop so-called Z-vectors from these SVD components, letting the model turn specific skill dials up or down in real time. When a new prompt comes in, the system checks which skill areas are relevant, picks the right Z vectors, and applies those adjustments to the base model. Then boom, you've got an on-the-spot optimized response, all without messing around with a big fine-tuning stage they call their overall process singular value finite tuning, or SVF for short. In experiments, they applied Transformer Squared to Llama 3 and Mistral LLMs, comparing the results to the usual LA baseline. According to SAC's blog, this new approach achieves better performance across diverse tasks like math, coding, reasoning, and visual question answering, and because it's adjusting itself dynamically, it's simply more flexible. Another cool finding is that these Z vectors can be moved between models of similar architecture. If you have a set of Z vectors trained on Llama 3, you might be able to use some of that knowledge on Mistral, though it performs best when you create fresh Z vectors for each target. They've also made the code open source on GitHub, so if you're feeling adventurous, you can dig right in. Now, what's the bigger picture here? Over the last year, everyone's been going wild trying to improve how LLMs perform at inference time, whether it's letting them remember more in their extended context window or training them in a unique way that doesn't need a ton of extra data. The idea is to make these models more efficient in user LY in real-world applications. In the case of SAC's Transformer Squared, you can see how it blends seamlessly into this theme. Enterprise users can quickly adapt their existing LLM to a brand new problem. That means faster development, lower costs, and just a more practical approach to handling specialized data. But that's not all for today's show. Right on the heels of SAC's announcement, a Chinese AI startup called DeepSeek released a model called DeepSeeker 1, which also deals with advanced inference time customization, but with a different Flavor where SAC's method focuses on singular value decomposition and dynamic weight adjustments. DeepSeek R1 is all about open reasoning and robust chain of thought processes. According to DeepSeek, their new model matches the performance of OpenAI 01, that's OpenAI Frontier Reasoning LLM, while running at a fraction of the cost, somewhere around 90 to 95% cheaper. That's a jaw-dropping reduction. So let's zoom in on DeepSeek R1 for a second. It's based on a mixture of experts model called DeepSeek V3, and apparently the team has made the entire thing open source under an MIT license. They not only built R1, but they also used it to distill multiple Llama and Qwen models, supercharging their performance in domains like math. Their Qwen 1.5b distillation for instance even outperformed bigger models like GPT-40 and Claude 3.5 Sonnet in certain benchmarks. Now when we say distill, we typically mean that you use a powerful teacher model to guide the training of smaller or specialized models, transferring knowledge in a more efficient way. DeepSeek seems to have done that on a mass scale with R1 to really drive home how strong R1 is. Check out its performance metrics. It hit 79.8% on AMI 2024 math tests and 97.3% on MAF 500, which is just a hair above OpenAI 01's 96.4% for that same test when they tested R1's coding chops. It clocked a 2029 rating on Codeforces, doing better than 96.3% of human programmers. It also notched 90.8% accuracy on the MMU test, that's just below zeros. 91.8%. So across these tasks we're talking about near parity with a top tier mod model, and again they're giving it away basically at a bargain, if not for free. If you have your own hardware and want to run it locally, the cost angle is really something to behold. According to DeepSeek, OpenAI 01 model is around $15 per million input tokens and a whopping $60 per million output tokens. On the other side, R1 is priced at only $0.55 per million input and $2.19 per million output tokens. That means if you're a startup or even a large enterprise that wants to run a lot of queries, you could see a massive difference in your monthly bill, and for some projects that could be a total game changer, encouraging more open innovation. Of course, the folks at DeepSeek also offer an API for direct integration, or you can grab the model weights on Hugging Face and run them yourself. They even have something they call DeepThink on their chat platform, which acts like an alternative to Chat GPT. Honestly, it's all pretty wild if you think about how much has changed in the open source AI space within just the last year or two. Now, how exactly did DeepSeek build R1? It's an evolution of something they call DeepSeek R10, which was trained purely with reinforcement learning, no supervised data at all. That zero-stage system picked up a bunch of advanced reasoning techniques by learning from scratch. Through trial and error over thousands of RL steps, it improved significantly on tasks like AIMM to 2024, boosting its PAS-1 from 15.6% to 71%, with majority voting it went to 86.7%. However, the devs found that while it got good at problem solving, the model's language usage was sort of, well, messy, occasionally mixing languages or producing text